Okay, next we are going to take a look at the example of the problem statement, which is related to the first order differential equation. The first problem we are talking about a rock which is contains two radioactive isotopes, which is Ra1 and Ra2. And the reaction just occurred like Ra1 decays into Ra2, which then decays into stable atoms. Ra1 is inside the rock and it is a radioactive material. When it decomposes, it's decomposed to be Ra2, and then Ra2 again decomposed to be a stable atom. Assume that the rate at which Ra1 decays into Ra2 is equal to 50 times the exponential of negative 10t. Because the rate of the decay of Ra2 is proportional to the mass of Ra2 present. So we can explain the rate of change in Ra2 as this equation. Our rate of creation is just come from the rate of Ra1 decay into Ra2. So we just plug the rate of Ra1 decay into Ra2 into the rate of creation. So we obtain this 50 times the exponential of negative 10t. And the rate of decay of Ra2 itself is proportional to the mass y. So we got ky. K is a constant. And then they define that k is greater than 0 and k is defined as the decay constant. They said that if k is equal to 2, the unit is per second, and the initial boundary condition is at t equal to 0, y is equal to 40 kilograms. Find the mass of yt of Ra2. So the things that, because this problem they just set the equation for you. Y is the mass of Ra2. We want to know, like, when time passed by, how much of Ra2 which is occurred from the reaction, and you know, because you know that Ra2 is occurred by Ra1, and also Ra2 itself decomposed into the stable atom. So we want to know that at the time that we are interested in, what would be the mass of Ra2 that still remain. Do you understand this? So if you look at this, dy by dt is the change of the mass of Ra2. It should be equal to the amount of it occurred minus the amount of its decay. So you would see the final, what would is left for Ra2. So that is the meaning of this equation. So they want to know the mass of Ra2 as a function of time. So if you know, like, if you solve this equation, you would get the equation which is represents the amount of Ra2 with respect to time. Then when you plug, if you know the time and you want to know how much that Ra2 is still left, you can plug into this equation. So the main point of this problem statement is just that they're just asking you to find yt, which is the mass of Ra2, as a function of t, as a function of time. If you look at the set of equations, what type of equation it is? It is a first order equation, right? What type of it? Now k is equal to 2, right? What type of this equation? Linear. So if you want to find the relationship between y, t, and t, you've got to solve. You've got to find a solution from this differential equation. And then, since you know this is a linear equation, so the way to find the answer is just what? We got to define px, right? And define qx. And then what? Find the integral factor, which is equal to exponential of integral px dx, which is equal to and then using our formula y is equal to 1 over integrating factor times the integral of integrating factor times qx dx plus c 1 over exponential of 2x integrate qx is what? We don't have x, we have t, okay, I'm sorry. Got to use the letter t instead because now t is our dependent variable. Just like that. Which is equal to e exponential of 2t and exponential times exponential of minus 10t equal to what? This term times this term is equal to what? Exponential of right? So when you do integral, you got to make this dt to be d minus 8t. Divided by minus 8. Get 50 divided by 8 e exponential of minus 8t plus 3. But they give you the boundary condition, then you can find t. You can find c. The boundary condition saying that at t equal to 0, y is equal to 40 kilograms. So you just plug the boundary condition into your equation. You would get 40 equal to e to the power 0 equal to 1. Okay? So c is equal what? 40 plus 50 over 8. So then you can write down the relationship between mass of Ra2 as a function of T as this. And your T supposed to have the unit of second, right? As the problem statement gives to you that your K is equal to 2 with the unit of per second. So anytime you Y is the mass of Ra2 and the mass of Y is supposed to be the units of kilograms. So now, if you know time, you can expect that what would be the amount of Ra2 at that time. This is one example. Any questions?